Here's the sketch from the previous video for a ESP microcontroller making connection to a Wi-Fi network by means of connection to some access point here. In this case there are a number of access points, so the sketch is choosing the strongest, the best one, and making connections with that one. And then the sketch is showing the IP address for the connection and the RSSI signal strength for it. But nothing else is here in order to establish connection to another unit. So that's going to change now, because now we will bring in another ESP microcontroller with this Wi-Fi utility and having the same sketch as this one from the previous video. So those sketches are now going to be modified in order to establish the connections between those two units here. So the first thing we have to do is to save these files, these sketches. So this is going to be saved as a server, and this will be saved as a client. Save as client, like that. So now we will modify the server first, because then the server is able to show its IP address, and that's necessary for the client to know in order to make a request for that server. So the first thing we like to do is to go to the global area here and insert some code for the instances for the server and client. The server is using port 50 here, and here's the client to make a request for the server. Then we go to the end of the setup routine here, and here we add some code in order to start the server. So now the server is running, but no data exchanges is made yet. That's done in this loop area here. So here we will first add the acknowledge of the with the instance of the client making the request to the server, and for that client, as long as it is connected, it will read the request from the server, from the client here. So if the client is available, then a message is read from the client and stored in this string variable line 1 here. We are using this read string until character return utility here in order to store the information, and the character return is included in this string variable here. And then this information is printed in a debug window, in a monitor window for the server. So we are using character return termination in a monitor window to achieve this character return here. So in addition, we like to also see if there is any information from the server. So if he has written any information in the monitor window data field in the server at the server monitor window, that's going to be read and stored in the string variable line 2 here, read in the same manner as above with this read string until character return utility here, and stored in the line 2 and printed and shipped to the client by this command here. So after that is done, we close this connected loop here, because if the connection is lost, the server will close the connection here, like that. So now we'll see if the brackets are in place here. We have to add more brackets here in order to close the loops here. So now we can try to compile this sketch here and see if this is working. So we push this compile and upload button here, and now it's compiling, and soon it will be uploading to the microcontroller. So now we are uploading here, and when the uploading is done, we can go to the monitor window and see what's happening with the connection here. So here we can see that the server has connected to the access point D-link here with this IP address ending with 149 as the IP address, and it's a very good signal here for the connection. So that's it. So now we have to modify the client. So the first thing we like to do here is to add some code in the global area here that is credited for the connection. The port 50 is used, and this IP address here, that has to be the same as here. So now it is the same address, so that should work well then. So then we go to the loop area. The first thing we do here is to insert an instance of the client. So after that, we're looking for any information written in the monitor data field window. So if that's done, that is stored in this line string variable here in the same manner as for the server. So we don't like anything to happen before we have written a command or information in this data field window in the monitor. So the request is made after that is done. So now when that is written and shipped to from the monitor window, we go on in the sketch and now we add a code for making the connection to the server. This is done here. So the connection to the server is tried to be made here with this host and port variables here. If the connection is failed, a message of that is shown. If that's not the case, that means the connection is successfully established. We go on in the sketch, and what we do next is to transmit the information from the line here, variable here, written in the monitor window in the client. That is shipped to the server, like that. Next, we will write some code for retrieving information from the server if that is present here, like this. But it can take some time for the server to respond for this information, so we have to add some code here waiting for the response to establish here. So we have a waiting loop here, while loop here, counting a variable from 0 to 3000. So within this time we can wait for the client for the information to retrieve. So we add this line code then for making sure that we have some time for the server to respond to the request here. So now we'll check for the brackets here. We have to add one more bracket in order to close all loops in the sketch. So now it seems that we have closed everything here. So now we can try to compile this sketch here for the client. So compile it. uploading it, and then we look into the monitor to see what's going on here. So the client has also made connection to the access point here with its own local IP address, and signal is good here. So now we write a command here, a dummy command like that, to see if there is any response with the server. And there are a message, new client is shown with the code here. So if you give another message here, that will also be shown here. Look, the client is disconnected immediately after the connection is done, because this server here is not a multi-thread server. The server is blocked for other client requests when it has connections with one client. So this client can block the server for accessing from other clients while it has the connection. So it's very important that this server close the connection when the data is exchanged here. So if it's not possible for the server to make any request or the data request to the client, that will stop. But if we make some new request here from the client, that will be acknowledged here, but now we also see that the information from the server is transmitted back to the client, and that's done every time the client is making a request. So if we make another request here from the server, and pay attention to this catch return here, we are using catch return to apply catch return to the message given here. So we enter that, but that is not acknowledged by the client here. But if you now go on and send a new request from the client, this message is appearing from the server. So now we have established a immediately connection between the client and server, closing down the connection as soon as the data exchanges has been done. Now we like to demonstrate another option here. It's possible to make a permanent connection between the client and server, not closing the connection each time there has been an exchange here of data. So if you do some changes here of the client here and move this client instance here outside the loop to the global area outside the loop here, we then are able to establish a permanent connection then. But here we can also add one line here, because here a new connection is made all the time, but here we can have that line where we test if there is a connection. So if it's not a connection here, a new connection will be made. But if there are already a connection, that would keep the connection as it is. In addition, we have to have a code for stopping this connection here, and we do that by adding one line here to test the line command given from the client. So if that command is a stop command, the client is stopping connection and the connection is broken. So that we have to do in order to achieve the goal we have to have. If we compile this sketch now, pushing this button here, the sketch is compiled, and here we have not closed all loops, so we have to add in brackets, another brackets here in order to close the loop here, and try once more to compile. And now we're compiling the sketch, and it's going to be uploaded soon. Today is going to be uploaded, And now we look into the monitor window when the uploading is done here. So now we see the connection is good. We clear the server monitor window. Now we see that the client has made connection to the access point here, the link, and locally IP address is here. Good signal. So now we try to ship a command here as a request to the server, and now we'll see if that's is in the response. Yes, it is. Here is the command received by the server, and now there are no connection closed here. So now we can send more commands here, like that, and we can also send some commands back to this from the server to the client. Now here it is, and here we can send another command back to the client, so we can have some commands going back and forth here now. So this is a could be a permanent connection, and in some cases that is a desire, even if that client is blocking that server for its own purposes. So no other client is now able to make any connection request to that server. But sometimes we like to do that. So, but in order to stop this connection, we have to use a fake command here, stop command, and now that stopped the client and then it stopped the server. So it's this test here for the command from the client. So if you hit stop command, the client is stopping, showing the command here in the window. So now you can also start again. New client is established and the message is passing to the server. So a second message is going also in the same sequence here, and here the server also are able to ship information back to the client continuously. And then stop command, close the connection there. So that's it. So now we have the both option with immediately closing the connection after exchanging the information, and in this last case we have an open continuously connection with the client and server. Thank you for watching.